I'm going to go through some of the main topics related to the memory hierarchy. A computer memory should be large, such as DRAMs, fast, such as SRAMs, and inexpensive. The memory hierarchy is to obtain the highest possible access speed while minimizing the total cost of memory system. Now looking into this four-level memory hierarchy pyramid, looking down till up, we will see that the cost per bit will increase, and that's because the time it takes to access the above ones is much more less than the time it takes to access the below ones, which are of larger capacity. The cache memory is a small storage device and it's of extremely high speed. The primary memory, which is the main memory, it stores the current data and instructions. The secondary storage here stores the data that we don't use that much and the programs that are not actively needed. As I said before, looking down till up, we see that there will be decrease in capacity, increase in cost per bit, increase in access speed, and decrease in access time. Next, let's look into this example. If we want to fetch some data found in the secondary storage, we'll pass the folder to the primary memory and the cache will take the specific file and send the data needed to the register for the CPU to execute the operation. Now let's talk about the register. It is the topmost memory device. It's close to the processor, fast, and small. Any data that needs to be executed later on by the processor will have to be stored in the register. Let's talk about the cache, which is the nearest to the CPU. All the recent instructions are stored in the cache memory. The inputs, which is given by the user, is going to also be stored in the cache memory. The thing is, if the processor searches for some data in the cache memory and doesn't find it, this is called a cache miss. Then what will happen then we will fetch the block of data from the main memory, copy it into the cache memory. Then the cache will send to the register bit by bit, and the register will send it to the ALU to perform the operation. As we said before, the data transferred from the main memory to the cache is block transfer, and from the cache to the CPU, it is word transfer, which is bit by bit. The hit ratio, you have to calculate the hit ratio. It is the number of hits, which is the success in finding the word in cache, over the total number of bus cycles, which is the total number of hits and misses times 100, and we will get the hit ratio. Now let's talk about the main memory. It stores data and programs during computer operation, and it uses some technology which is called the semiconductor technology, which is also known as semiconductor memory, which is divided into two types. What are these two types? Volatile and non-volatile. Volatile means that the data is temporary. That means when we are working and we turn off the computer, nothing will be saved. While a non-volatile, the data will be saved even after turning off the computer. This means the data is permanent. The one chip is not that sufficient. So mainly we use two or more chips. For example, the RAM and the ROM both are important to be present in the system to maintain a more efficient program for a certain memory size needed. The virtual memory, it appears to be present, but it's not present at the same time. It just gives an illusion to the user. For example, if a programmer wants to write a program which requires more memory found, then this program will be executed by the virtual memory technique. Looking into this example, if we have the real memory of 4 GB and we have the virtual one which of 16 GB, and the program is about 10 GB, it will be executed by the virtual memory of 16 GB. Let's state some points related to the virtual memory. Only part of the program needs to be in memory for execution. Logic address space can therefore be much larger than physical address space, allows address space to be shared by several processes, more programs running concurrently, requires less inputs and outputs to load or swap the process. Now let's look at this as a small illustration. We have the virtual memory, which only uses the concept of pages. We have the physical memory, disk, and the memory map, and the CPU receiving or sending the data. Then from the virtual memory to the memory map, it's going to be stored either in the physical memory or in the disk. And this differs if the physical memory, which is the main memory, is full, then we're gonna swap the pages that we don't use that much to the disk. And if there is some page that is not found in the physical memory and we need it, it's going to be fetched from the disk. Now let's look about now let's look at these four ships we talked about before. We have the RAM, which is of temporary data. We have the ROM, which is of permanent data. We have the DRAM, which is large, and we have the SRAM, which is fast. And thank you.